Welcome, everyone. Today, we're diving into a transformative workflow in software engineering, connecting Playwright for automated end-to-end testing using Claude Code. We'll explore how to bridge your AI assistant directly to your browser environment, enabling it to write, run, and self-heal your test suites. Let's get started. Let's begin by defining what we mean by agentic end-to-end testing. Traditionally, writing Playwright or Selenium tests is highly manual. You inspect the DOM, find selectors, and write sequential scripts. But with Claude Code, we are shifting to an agentic model. The basics involve turning Claude from a simple code generator into an active participant in your testing lifecycle. Why is this so revolutionary? Because standard E2E tests are notoriously brittle. A simple CSS class change breaks the pipeline. When you use Claude, the AI can observe the failure, understand the UI change, and self-heal the test. How we do this is by bridging Claude directly to your browser. In our deep dive, you'll see this transforms testing from writing static assertions into providing goal-oriented instructions to an autonomous QA engineer. Take a look at this comparison flowchart. The top path represents what you are likely doing today, traditional testing requiring manual scripting, which inevitably leads to high maintenance and brittle tests. The bottom path is where we are going. Agentic testing utilizes Claude to generate the scripts. Because Claude can read the execution output, it results in the green node, self-healing, and adaptive tests. This is a massive leap in engineering productivity. To make Claude control a browser, we need a bridge. That bridge is the Model Context Protocol, or MCP. What is MCP? It is an open standard that connects AI models securely to external tools. The basics rely on a client-server architecture where Claude Code is the client. Why do we need this? Because an LLM is essentially a text prediction engine. It cannot physically open Google Chrome. MCP solves what the industry calls the NXM integration problem by acting as a universal adapter. How it works is that the Playwright MCP server exposes browser commands as tools. In our deep dive, we see the true power. Claude sends a structured JSON request to the server runs the actual Playwright automation, and then returns the result like a success message or a stack trace directly back into Claude's working memory. This architecture diagram maps the exact communication flow. At the top, your Claude Code CLI acts as the brain. When it needs to test a UI, it sends a JSON RPC request to the Playwright MCP server, highlighted in orange. The server then translates that into actual browser commands, launching a headless browser and navigating the page. The browser executes the action and sends the DOM state back to the server, which packages it as tool output and feeds it back to Claude. Let's get practical and actually connect Playwright. What we are doing is registering the Playwright MCP server so Claude Code can see it. The basics involve running a simple CLI command that updates your configuration. Why must we do this? Claude operates in a secure sandbox by default. It doesn't automatically know you have Playwright installed until you explicitly bridge it. How do we do this? Look at the sample code on the slide. You type Claude MCP add Playwright npx at playwright/mcp at latest, suser. This instructs Claude to pull the latest Playwright MCP wrapper using npx. For our deep dive, pay close attention to that suser flag. This applies the configuration at the user scope. This means whether you are testing a React app in one folder or an Angular app in another, Claude will always have its browser automation tools ready to go. Here is the sequence of events when you run that setup command. The developer sends the command to Claude Code. Claude Code immediately reaches out to the NPM registry to fetch the official Playwright MCP package. Once downloaded, Claude writes the server connection details directly into your global configuration file. Finally, it confirms to the developer that the new tools like opening pages and clicking elements are officially exposed and ready to use. Once connected, we need to know how to prompt Claude effectively. This is where context engineering comes into play. The basics require you to stop giving vague commands. You must provide the component files and explicit success criteria. Why? Because the absolute highest leverage thing you can do when working with Claude Code is giving it a way to verify its own work. If it doesn't know what success looks like, it will hallucinate. How do you prompt it? You use the @ symbol to reference your UI file and explicitly instruct it to write a Playwright test and verify the login flow. In our deep dive, we solve the issue of inconsistent team tests. By placing your testing conventions in a claude.md file at your project root, Claude automatically reads your rules every session. It ensures every generated test matches your enterprise standards perfectly. This flowchart maps out the perfect test generation prompt. The developer prompt combines two things: the target file using the mention, and the specific acceptance criteria. Simultaneously, the Claude.md file silently injects your team's testing standards into the green Claude Code engine. The engine synthesizes all of this context to generate a highly standardized, accurate Playwright script that perfectly targets your application's logic. Generating the test is just step one. Now we look at autonomous test execution and self-healing. What does this mean? It refers to the agentic loop where Claude actually runs the test it wrote, observes the output, and fixes its own mistakes. The basics: Claude has bash tool access. It can literally run npx Playwright test in your terminal and read the results. Why is this revolutionary? Because UI tests almost always fail on the first run due to tricky selectors or async timing. Claude becomes your active debugger. How do you trigger this? You prompt, run the tests. If they fail, analyze the error, fix the code, and rerun until green. Our deep dive shows this is the ultimate observe plan act loop. When Playwright throws a timeout error, Claude reads the stack trace, realizes the button ID changed, rewrites the test file, and executes it again. It's fully automated self-healing. Follow the state diagram to see the self-healing loop. Claude starts by writing the test, then transitions to execute Playwright. If the tests are green, it passes and the workflow is complete. But if it hits a fail state like a selector timeout, it enters the subprocess. It reads the standard error, analyzes what changed in the DUM, updates the test script to fix the broken selector, and loops right back to execution. It repeats this until the tests pass. Let's push the boundaries with visual verification and UI automation. This is where we combine Playwright's browser control with Claude's advanced vision capabilities. The basics: we aren't just checking if a button works programmatically. We use Playwright to take a screenshot of the live app and hand that image back to Claude. Why? Because functional code can still be visually broken, and standard tests are terrible at checking if a page looks right. How we do this is by having Claude command the MCP server to capture the page state. In our deep dive, we see this enables subjective testing. You can literally prompt Claude to open the development server, take a screenshot, and verify if the newly built hero section aligns with your company's brand guidelines. Claude acts as an automated design reviewer. Look at the workflow for visual QA. The prompt to verify visual design triggers the Playwright MCP. The browser renders the page and captures a screenshot. This screenshot is fed into the yellow node, Claude Vision Analysis. Here, the AI literally looks at the image. We hit a decision gate. Does it match the brand guidelines? If yes, QA is passed. If no, Claude immediately generates the CSS fixes required to align the design. Let's look at a real-time, highly valuable use case: e-commerce checkout testing. The scenario: your team just completed a massive React refactor, and you must ensure the critical checkout flow still works. For execution, you open Claude Code and prompt, write a Playwright test that adds an item, goes to the cart, and fills out shipping. Run it and fix any issues. Here is the problem: the refactor unknowingly changed the checkout button's ID. When Claude runs the initial test, it fails. But here is the agentic fix: Claude doesn't give up. It reads the Playwright error trace, uses MCP to query the live DOM, discovers the new ID is submit order, and rewrites the test file autonomously. The value here is immense. What usually takes a QA engineer an hour of tedious debugging is solved in minutes, leaving you with a perfectly verified test suite. This journey map highlights the emotional and technical highs of the process. In the setup phase, the developer provides instructions and Claude generates the script. In the middle section, execution hits a low point. The test fails due to a missing ID. But then we enter autonomous recovery. Claude analyzes the DOM via MCP, rewrites the test selectors, and reruns the suite to total success. The system recovers itself perfectly. Let's wrap up with best practices for scaling your tests. First, use explicit assertions. AI is brilliant, but you must define what success looks like. Second, leverage subagents. If you have a massive test suite, spawn a dedicated QA subagent to handle the heavy lifting so you don't pollute your main conversation context. Third, always keep a human in the loop. Playwright can perform destructive actions, so always review the generated scripts before letting Claude run them against production databases. Finally, maintain your project memory. Keep your evolving testing standards in the Claude.md file so Claude stays aligned with your team style. Master these agentic workflows, and you will become an invaluable engineer. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Thank you for watching. Our final mind map illustrates the 4 pillars of testing mastery. From the center, we must secure project context using Claude.md and explicit assertions. We utilize agentic execution via the Playwright MCP and subagent isolation. We enforce safety and scale through human review and non-destructive environments. Finally, we commit to continuous learning by constantly analyzing failures and refining our prompts. Master this, and your CI/CD pipelines will be unstoppable.